Hey there, curious minds. Ever wondered why some data problems are a breeze to solve, while others are super tricky? Today, we're putting on our detective hats to investigate the fascinating world of separated, unseparated, and imbalanced datasets. Get ready to uncover the secrets behind clean and messy data. Before we dive into the nitty-gritty, let's quickly chat about what a dataset even is. Think of it like a giant digital shoebox filled with information. Whether it's a spreadsheet full of numbers, a folder of customer reviews, or a collection of images, a dataset is simply all the raw information we gather to help us understand something better. It's the foundation for any computer learning. First up, let's talk about separated data. This is the dream scenario for computers. Imagine you're sorting a basket of bright red apples and green apples. It's super easy to tell them apart, right? In data terms, separated means the different categories or groups in your information are clearly distinct from each other, with obvious boundaries. This makes it incredibly easy for a computer to learn patterns and make accurate predictions. Now, what about unseparated data? This is where things get a little blurry. Picture that same basket of apples, but this time, you have dark red apples, slightly less dark red apples, and some that are kind of reddish green. It's much harder to sort them neatly, isn't it? Unseparated data means the groups overlap a lot, making it difficult for computers to find clear dividing lines. This can make their learning process much harder and lead to more mistakes. So, why should we care if our data is separated or unseparated? Well, it directly impacts how smart your computer can get. When data is clearly separated, the computer can learn very specific rules, leading to excellent accuracy. But if the data is all jumbled together, the computer gets confused, and its learning becomes less reliable. Think of it as teaching a child. Clear examples lead to clear understanding, blurry examples lead to confusion. Next, let's tackle imbalanced data. This one's a bit unfair. Imagine you have a photo album with 99 pictures of your cat and just one picture of your friend's dog. If you show this album to someone and ask them to guess if the next picture is a cat or a dog, they'll almost always guess cat, right? That's imbalance. It's when one group in your data has a huge number of examples, and another group has very, very few. The computer tends to focus on the common group and might completely ignore the rare, but often important, one. Imbalanced datasets pop up in many real-world situations. For example, when doctors try to detect a rare disease, most patients are healthy, and only a tiny fraction have the illness. Or, consider credit card fraud detection. Most transactions are legitimate, while only a small percentage are fraudulent. Even predicting natural disasters like earthquakes or tsunamis involves imbalanced data, as calm days far outnumber disaster days. In these cases, ignoring the rare event can have serious consequences. So, how do we fix this unfair game of imbalanced data? We have a few tricks up our sleeves. Sometimes, we can collect more data for the smaller group. Other times, we might resample our data, either by making copies of the rare examples or by carefully removing some of the abundant examples to create a more even playing field. There are also special computer algorithms designed to pay extra attention to those rare, but crucial, instances, ensuring they don't get overlooked. And there you have it. From clearly separated data to tricky unseparated and unfair imbalanced datasets, you've now got a fantastic overview of how different data structures impact a computer's ability to learn. Understanding these concepts is a super important step on your journey to becoming a data-savvy individual. Keep exploring, keep learning, and don't forget to hit that subscribe button for more simplified tech explanations.